Hi, how are you? Hope you all are doing good. So today we will discuss the ionic product of water. This is very important and very nice topic. Okay. So basically you know that the most important property of water is its ability to act as either Bronsted-Lowry base or Bronsted-Lowry acid. What it means? So basically it means that water can act as a proton donor as well as proton acceptor. Let's see. Suppose I take a water molecule, H2O, plus another water molecule. So what will happen here? A very nice phenomena known as auto-ionization. Auto-ionization. So this water molecule, let me mark it as A and let me mark it as B. So this A water molecule, what will it do? It will gain, okay, it will lose a proton. So basically after losing a proton, it will change into OH negative, correct? And the B water molecule will accept a proton. After accepting a proton, it will change into H3O positive. Fine. So means water is gaining proton as well as losing proton. So this water molecule is acting as an acid and this water molecule is acting as a base. So this is known as auto-ionization. Fine. We call this process as auto-ionization of the water. Okay. Now let me tell you a fact. So you know about only 2 out of every 10 to the power 9 water molecules are ionized at a given moment. Like out of this much, only 2 water molecules would be ionized at given temperature condition to be 25 degrees Celsius at normal temperature conditions. Fine. I hope this is clear. Auto-ionization means water will act as proton donor as well as proton acceptor. Okay. So, okay, let us write the, now what is ionic product of water? Ionic product of water. So let us again write the auto-ionization one, H2O, liquid plus H2O in equilibrium with OH negative aqueous plus hydronium ion. Okay. So I hope you know how to write the equilibrium constant of this reaction, which would be Kc. So Kc equals to OH negative product concentration by reactant concentration. So I won't be writing here water concentration. So can you tell me why water is excluded in this? Okay, do comment it. Why water is excluded in this concentration? Okay. So now auto-ionization of water, this is the equation for auto-ionization of water. So instead of representing it with Kc, what we will do, we will represent it with Kw. So Kw equals to OH concentration and hydronium ion concentration. Okay. I hope this is clear. Fine. So basically, this value is experimentally calculated. Like this value is calculated experimentally and at 25 degrees Celsius, which is normal room temperature condition, this is 10 to the power negative 14. So Kw at 25 degrees Celsius is 10 to the power 14. So basically, let me write the whole equation for you. Kw is equal to H positive concentration, concentration of OH negative equal to 10 to the power negative 14 at 25 degrees Celsius. Okay, now you need to remember few things. So what is a neutral solution? I hope you know the neutral solution, like neither acidic nor basic. Okay, a solution is acidic because of the presence of, a solution would be acidic in nature if it has H positive, and solution would be basic in nature if it has OH negative, correct? So if the concentration of H positive ions and concentration of OH negative ion is equal, the solution would be neutral in nature, neutral solution. And if the concentration of H positive ion is more than OH negative ion, the solution would be acidic in nature. And if the concentration of OH negative ion is more, like the concentration of OH negative ion is more, the solution would be basic in nature. Okay, just remember these three things. Neutral means H positive and OH negative are equal. Acidic means H positive is more, and basic means OH negative concentration is more in the solution. Okay. So basically in most of the solutions, H positive and OH negative concentration are not equal. Like, okay, normally they are different. So as the concentration of one of this increases, the concentration of other must decrease. Now what it means? See, suppose if I say, let me take left hand side and right hand side. So let us assume that left hand side is 3 and right hand side is 6. So the product would be 18, correct? And if I say this value is fixed, okay, so this value 18 is fixed. So let me make left hand side 2. So the right hand side will automatically be equal to 9, correct? Because this needs to be constant. This needs to be maintained at 18. Similarly, if I say left hand side is 6, then right hand side should be equal to 3, correct? Then only it will be equal to 18. So same is with the water. So H positive concentration and OH negative concentration is equal to this. Remember, temperature is 25 degrees Celsius. So if this concentration increases, so this has to decrease because the product has to be a constant value. Okay. On the other hand, if this decreases, this has to increase again because the product needs to be a constant, which is 10 to the power negative 14. Okay. Just remember the temperature, 25 degrees Celsius. Now let us solve few questions. Okay. Calculate a value of H positive ions and OH negative ions in neutral solution at 25 degrees Celsius. Okay, now here, so I will solve this question for you. Now here they have given us that solution is neutral and we have to calculate the concentration of H positive and OH negative. Remember, they have given us the temperature also, which is 25 degrees Celsius. Okay, so basically we know that at 25 degrees Celsius, Kw is equal to 10 to the power negative 14. And for the neutral solution, H positive concentration is equal to OH negative concentration, correct? Okay, so you would be like, okay, why I'm writing H positive? So here, like where we mentioned the ionic product of water, So instead of hydronium ion, we can use H positive also. Okay. So H positive and hydronium means basically they are same. So they are different symbols given just. So you can just use them. Okay. Fine. Yeah. So for the neutral solution, we know that H positive concentration and OH negative concentration are equal. So let us write the equation. Kw equals to OH negative concentration and H positive concentration. So since both are equal, so what I will do, OH negative concentration, and here also I can replace it with OH negative, correct, equals to Kw. So 10 to the power negative 14 equals to OH negative square. So the concentration of OH negative would be 10 to the power 7, correct? Similarly, since both are equal, H positive concentration is equal to OH negative concentration, which is 10 to the power negative 7. So for the neutral solution, H positive concentration and OH negative concentration are 10 to the power negative 7. Fine. Just remember this. I hope this is clear. Okay. Now your turn. So just remember one thing I will be writing here. In neutral, wait. Yeah. In neutral solution, H positive concentration and OH negative concentration equals to. So this will help you in solving the question. So question is, you have to predict whether the solution is acidic, basic, or neutral. If concentration of H positive ion is 4 into 10 to the power negative 9 mole per decimeter cube, OH negative ion is, so this is A part, this is B part, mole per decimeter cube. And for the C1, concentration of OH negative is 7 into 10 to the power 13 mole per decimeter cube. Okay, pause the video and predict it. Okay, so basically for the first one, if you see, so we know that in the neutral solution, the concentration is this much. So now this is less value, like lesser than 10 to the power negative 7. So this would be, so means H positive ions are less. So that would be a basic solution, because if H positive ion concentration is less, the solution would be basic. Now next question. OH negative is given as 10 to the power 7, which is, we know that, neutral solution. And for the third one, the concentration of OH negative is 10 to the power negative 13. So negative 13 is a very small number. This is a very small number, which is like really smaller than 10 to the power negative 7. So this means the concentration of OH negative is really less. So the solution would be acidic. Fine. Okay. Now let us solve one more question. So calculate concentration of H positive in a solution, okay, in which OH negative concentration is 0.01 mole per decimeter cube. So this is the A part, and the B part is in which OH negative concentration is 1.8 into 10 to the power negative 9 mole per decimeter cube. Okay, so pause the video and try it. Okay, so basically we know that. So here we will, if it is not stated, so assume the temperature to be 25 degrees Celsius. Otherwise, if the temperature is different, they need to give us kW for that given temperature. But here they haven't mentioned. So we will assume temperature to be 25 degrees Celsius. Okay. So we know that H positive concentration and OH negative concentration is 10 to the power negative 14. Correct? So here they have mentioned OH negative concentration to be 0.01. So H positive concentration times 0.01 is equal to 10 to the power negative 14. So H positive concentration comes out to be 0.01 divided by 0.01. So which would be 10 to the power 12, negative 12 mole per decimeter cube. Okay. So you can solve the next question also. I will be mentioning the answer for the next question. It is 5.6 into 10 to the power negative 6 mole or mole per decimeter cube. Mole per decimeter cube. Hope this is clear. So this is really an important concept. Do revisit the video. If it is not clear, or comment, I will try to explain it in more advanced way. Okay. So for your thinking, for you, there is a question. Calculate concentration of OH negative ions in a solution in which H positive is 2 into 10 to the power negative 6 mole per decimeter cube. So you need to answer this question. As you know, you can send your answer at our email ID, which is wisdomscience25@gmail.com. Fine. And one more important information. We provide one-to-one tuition classes also on any topic you want related to chemistry. So if you want one, you can mail us on wisdomscience25@gmail.com. Okay, I hope this concept is clear. So think it and mail your answer. We will check it and we will revert back. Okay, so if you like the video, do share it and subscribe it. Thank you. Bye-bye.